Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, I'm going to show you how you can read the superblock with some simple Python scripts. Now, before we start on this, you might ask, why would you want to do this? After all, we do have things like the sleuth kit. Well, there are a couple reasons you might want to do this. The first reason is that the sleuth kit I've found is not necessarily completely up to date. So it won't always get all of the fields out of the superblock for a recent file system. Another reason is that we're trying to build a library of Python classes here, and having this done yourself allows you to go in later and make some modifications and do other powerful things with Python. So let's have a look at the script. So here we are. It starts out with our usual shebang, user bin Python. We import some standard stuff, and then I have a few helper functions. Now these helper functions will read in a packed string and convert them to unsigned integers of various sizes. So I'm using the Python struct unpacked, and I just made one for 32-bit, 16-bit, 8-bit, 64-bit, and 128-bit numbers. I also made a little helper function to print UUIDs. Made another helper function to get the compatible features list. So this is stored, recall, in a bitmap, and this will take that bitmap and convert it to a nice human readable list of features. So here are some compatible features, and I have something similar for incompatible features, and again for read-only compatible features. And then we get to our actual class. So the class is just called superblock. And in Python classes, every method in the class starts with a parameter of self. And this method is no different. This is the constructor. So we define this to be a method named _init_, and that is the constructor that gets called whenever you create a new object in Python. So in this case, when I create a new superblock object, I pass it the 1K of bytes that make up a superblock. I pass that in data. So if you look at this code, it's pretty straightforward. It's a bit lengthy, but straightforward. And here, I'm just calling all of these functions like get u32 on my data, get u32 again with an offset into that data, etc. So this will read in that information. There are a couple of fields that are not quite as straightforward, such as these. Here, the block size is stored as a power of 2 greater than 1024. So in other words, if the value stored in this field is 0, you have 1K blocks. If it's 1, you have 2K blocks. And if it's 2, you have 4K blocks, which is what we normally have. Cluster sizes, if they're in use, work similarly. We have a couple of fields that store seconds since the epoch, and this construction here just converts that into a time object in Python. Here we have more generic things, another timestamp, etc. The only thing that's a little bit different, notice here I read in the features bitmap and then I convert it to a list using that helper function I showed you earlier. And similar things happen with the other feature bitmaps. There are a couple of arrays stored in the superblock. So you might see a couple of little for loops for reading those, and so on. I also define a couple more helper functions. One of them is called print state, so it will take the status and print out what it really means. And there's something similar for error behavior and the creator OS and hash algorithms, encryption algorithms, and so on. I then define this method called prettyprint. Now, prettyprint makes use of an interesting feature of Python. Every class has internal to it a dictionary, and here I'm using that dictionary and I'm iterating over it in order to print out the entire thing. This allows you to print something out without creating a very long function. You can see this function is fairly short. If I iterated over every single item in this class individually, it would be much longer. Here I have a standard usage function that says, if you're calling this directly, please give me an image file and your offset in sectors into the file system. I have a main method that says you didn't give me enough parameters, so I'm going to give you usage. And here this is pretty simple. I try to open the file. First I check to see if it exists, and then I use the recommended construct with open. I seek ahead 1024 bytes, because recall that the superblock starts 1024 bytes into the file system, and I add to that anything that you passed in, the sectors offset times 512 that you passed in on the command line. Once I do that, I read 1K bytes of information. I then pass that into my superblock object, and I call prettyprint. This last bit is a common Python construction that you will see, where it says if double underscore name double underscore equals equals, and then in quotes double underscore main double underscore, then do something. In this case, call main. And what this allows you to do, this allows you to create a Python script that can be run or imported into another script. So again, recall that we said that we might want to take this script and use it elsewhere later. So let's go ahead and run the script. So here I am. I'm going to run my script, and the script is called xfilesystem.py. I will run it against my image, which is at media, fill, Toshiba, disk, images, 2015, 3.9, IMG, and my offset was 2048. And I run it, and boom, it's done. So you can see that I printed out several things. So let's just, for example, look at the read-only compatible features list. So I have sparse super, large file, huge file, group descriptor table, checksum, directory end link, and extra size. So I have 6 parameters. And by way of comparison, if I go back to my editor, I can see here I have 1, 2, 3, 4. So obviously something has been left out by the sleuth kit, and we'll see that there's other omissions as well if you pick through all of this information. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon.